argument of a complex number. Argument of a complex number. So in this video, I'm going to be learning the argument of a complex number and how to, derive the argument of a complex number appropriately. First, we need to define what an argument is. The argument of a complex number is defined as the angle inclined. The argument of a complex number is defined as the angle inclined from the real axis. You get that now? From the real axis in the direction of the complex number represented on a complex plane, denoted by theta. Okay, that means when we are asked to find the argument of a complex number, we are saying that find the theta, denoted by theta. Okay, and it is measured in radian. Measured in radian. So you have to note all these words. Now you need to recall that complex number is a field of extension of real numbers, right? It's the field of extension of real number in the form z is equals to x plus yi. You know this one, right? Good. So, but before we can accurately get the argument of a complex number, we need to implement the knowledge of what is called the Argand diagram. The Argand diagram. Now, the Argand diagram is a diagrammatic representation of complex number, right, on a plane. Is a diagrammatic representation of a complex number on a plane or on a complex plane. So know that an Argand diagram. That's right, the Argand diagram. Okay, Argand diagram. So that's a representation. So mathematically, if I want to obtain my argument theta, okay, argument theta is equal to the arctan of what? Y over x from this form here, y over x. That's how to find my theta. To find your theta, you need to know that you have your what? Arctan y over x. And mind you, when you are obtaining your theta, don't include the symbols, right? Don't include the symbol. We are going to sort it out on the Argand diagram. Now, what is an Argand diagram? Let me quickly give you what an Argand diagram is, so you can understand what I'm talking about. Now, this is an Argand diagram here. It looks at some examples, so you can actually know what I'm actually saying. Let me put this one side, put this one here. Okay, good. So let's assume I have an example to solve like this. So find the argument of this. Find the argument of this 2i plus 2. You want to find the argument of this one. This is your x, right? This is representing your x. This is your y. Your y is what has the I, right? So I'm going to have my argument theta to be what? Arctan of y over what? X. And that's the same as writing arctan of 2 over 2. And that is arctan of 1, because 2 into 2 is 1. Okay, so arctan of 1 is 45. Now that 45 degree falls here, so we don't need to do any subtraction. So that will be the argument for this complex number, right? Yeah, suppose you are given something like this again. Suppose you are given another question like this. The argument of w equals to 4 minus 5i. Now here we can see that this is my x, this is my y. Alright, so my argument theta is arctan y over what? Over x. So to find this, don't include the symbol, the sign, just write the numbers alone. So my y is 5. Forget about the minus. Okay, forget about the minus. Then I'll have what's it called again? I'll have 4 here. Okay, so if I should do arctan of 5 over 4, I will have 51 0.34, but this is not my final answer. I will get to know the correct answer after I must have represented this on an Argand diagram. Okay, let me clear up this part so we can draw our Argand diagram. This is my diagram here. Okay, now on the x-axis we have 4, right? And 4 should be somewhere here, plus 4. While on the y-axis I have minus 5, so minus 5 is somewhere here, minus 5. So in that case it should be somewhere here. If I want to carefully plot it, it should be somewhere here, right? So it falls where we have 360 minus theta, which means that whatsoever you get here, you should do 360 minus the answer, because it falls in this quadrant, 4 and what, minus 5. So we now have my argument will be 360 minus 51.4, right? Which will be 308.66. so this will be the argument of this complex number. Okay, let's do another example so I can understand it very well. The thing is, don't put your sign when you are computing it. Okay, just go to your Argand diagram to plot this on the x-axis, this on the y-axis, and you definitely get your answer. Okay, let's do another one. Suppose you have a question like this. Suppose you are given W and you should find the argument of minus 6 minus 2 minus 6i. So first thing you want to do is to find the arctan of 6 over 2. Okay, 6 over 2, and that's the same as saying the arctan of 3. So the arctan of 3 should give you, after using your calculator, you have 71.565. So you need to plot this on your Argand diagram to know the final answer. So this is your x, this is your y. So on the x-axis we have minus 2. On the y-axis we have minus 6. So it should be your plotting is somewhere here. Okay, somewhere here. In that case, it falls at this part where we have 180 plus theta. That means whatever you get, we are going to add 180 to it, which means this will be plus 180 to get your final answer. And therefore your theta will be what? Your theta will be 251.565. That's how to do the argument of a complex number.